friends, welcome to the Kiran Ajit Rao's YouTube channel. In this video, we're going to cover uniquely decodable codes. So, for that, we need some basic information related to the uniquely decoded code. The set of binary sequence is called as code, and the individual members of the set are called as code words. An alphabet is collection of symbols called letters. We can take an example of ASCII code. We can have a code for a small letter A as 10000011 and for capital letter A as 10000001. And for a comma, it can be coded as 0011010. So if we see the length of code in each and every alphabet or for the symbol, it is same. In such type of codes like the ASCII code uses the same number of bits to represent each symbol. Such a code is called as fixed length code, as for each symbol a fixed length of code is given. The average number of bits per symbol is often called the rate of the code. In uniquely decodable codes, when we transmit any code from transmitter, one should be able to decode them without any ambiguity on receiver side. This methodology is termed as uniquely decodable codes. The average length of code is not the only important point in designing a good code, but the code should have the ability to transfer information in an unambiguous manner. A symbol to be assigned a unique code word. As we can say, whenever we talk in terms of codes. So whatever we speak is decoded by the other person. So in between two persons, we have a mode of communication, that is language. The same coding is used in terms of any type of communications. So we'll take one example of binary coding sequence. Here we have letters A1, A2, A3 and A4 with probability of 0.5, 0.25, 0.125 and 0.125 for A4. And there are four different codes that are designed. Code 1, code 2, code 3 and code 4. In code 1, A1 is coded as 0, A2 as 0, A3 as 1 and A4 as 10. Likewise, code 2, code 3 and code 4 are coded. Now, to find the average length, we have the formula as average length L is equal to summation of I is equal to 1 to the number of codes as we have given at the 4 codes. So it is I is equal to 1 to 4. Probability of AI into N of AI, where N of AI is nothing but it is the number of bits in the code word for letter AI. So number of bits for first code for A1 is 1 bit, for A2 it is 1, A3 is 1 and for A4 we have 2 bits. Similarly, for code 4, for A1 it is 1 bit, A2 is equal to 2 bits, for A3 is equal to 3 bits, for A4 is equal to 4 bits. So we'll see how to calculate this length of code and right here at the bottom. So for calculation, L is given as summation of I is equal to 1 to 4 probability of AI into NAI. So for code 1, we have probability of first letter A1 is 0.5 into length of code is 1. So 0.5 into 1, second plus 0.25 into 1, then plus 0.125 into 1, then plus 0.125 into 2. So it comes out 1.125. So this is what the code length for code 1. Similarly, we can calculate it for code 2 as 1.25, for code 3 1.75, code 4 1.875. Now we'll learn what are the problems when we code any alphabet or letters. Now for code 1, we have A1 is coded as 0, A2 as 0, A3 as 1 and A4 as 1 0. So in this case, if we transmit A1 and A2, we'll find A1 is equal to 0, A2 is equal to 0, which has the same codes. So for code 1, based on the length, the code 1 is best code. But as A1 and A2 are assigned same code word 0, so it is difficult to interpret whether A1 or A2 is received. So it is difficult to interpret whether A1 or A2 is received at the end. Each letter should have the unique code word. So this is what difficulty in code 1. Whereas in code 2, all are distinct codes. So A1 as 0, A2 as 1, A3 as 0 0 and A4 as 1 1. So all are different code words which are given to them. But if we transmit A2, A1, A1, so this comes out to be A2 is equal to 1, A1 as 0 0. So this comes out 1 0 0. And if we transmit A2, A3, then that also comes out to be 1 0 0. So in this case, receiver may decode the sequence as A2, A3 when we transmit A2, A1, A1. So the original sequence cannot be recovered. Hence, it requires the unique decoding. Now coming to the code 3. Code 3 is uniquely decoded. So there is no problem or there is no such an ambiguity as in code 2. So each code is differently coded and it is ended with 0 0 0. The first 3 code words end with 0 and the 4 does not contain 0 at the end. So we need to apply a decoding rule as accumulates the bits until you get 0 at the end or until you get the 3 ones. By using this decoding rule, we can easily send and interpret the same bits at the receiver. It shows that it has uniquely decodable property. Now coming to the code 4, it is also decoded in the same way. So it is having starting bits as 0 and end bits for later on 3 is as 1. So in code 4, each code word starts with 0. So here we can apply the decoding rule as accumulates the bits until you see 0. The bit before the 0 is the last bit of the previous code word. So the problem is that we need to wait for the another bit to start. So based on code 1, 2, we have some observations that we already discussed. Based on code 3 and 4, little bit more observations are as there is a slight difference between code 3 and code 4. In case of code 3, the decoder knows the moment code is complete because as it is ending with either 0 or it is ending with 3 ones and which is already given in the rule. In case of code 4, we have to wait till the beginning of next code word before we know that the current code word is complete. Because of this property, the code 3 is called as instantaneous code, although the code 4 is not an instantaneous code. If you find this video useful for you, then please like, share and give your suggestions in the comment box. Subscribe the channel for the upcoming videos and do not forget to press the bell icon for the notifications. Thank you very much for watching the video and giving your valuable time.